Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the role of asymptotes in log graphs. Now, we've seen asymptotes before, for example, when we graphed exponential functions. Asymptotes are like no-go zones of a graph. They're areas of the Cartesian plane that the graph can't cross. So why are there asymptotes in log graphs? Well, it's because of this rule here. So this says if you take a positive number and raise it to any power, the answer is always positive, no matter what the power. So we know this. For example, if I have 2 to the power of x, doesn't matter what power I put here, the answer is always going to be positive. So even if x is negative, 2 to the power of minus 4 is 1 over 16, which is positive. 2 to the power of minus 1 is a half, which is positive. 2 to the power of 0 is 1, which is positive. No matter what number I put for x, whether it's positive or negative, 2 to the power of that number has to be strictly more than 0. So what does this have to do with logs? Well, remember, logs are the opposite or the inverse of exponentials. So if I have something like log base 2 of x, I'm saying, to what power do I raise 2 in order to get x? So I can only put a positive number here. I can't do something like log base 2 of negative 1 because there's no power of 2 that equals negative 1. That's not possible. So when I'm looking at log base 2 of x, the x value has to be more than 0. It can't equal 0. There's no power of 2 that equals 0. So if I want to graph y equals log base 2 of x, it will have an asymptote at x equals 0. And this asymptote is a no-go zone. This graph will not be able to hit anywhere on the Cartesian plane where x equals 0, because we know x has to be greater than 0. So it turns out, and we'll see this in later lessons, log graphs kind of look like this. So what happens is, as the x value gets closer and closer to 0, this line here gets closer and closer to, but never hits the y-axis. This line here, the y-axis, is x equals 0. That is an asymptote of the green graph. The green graph can never hit it because if y equals log base 2 of x, x has to be a positive number. So that's what asymptotes mean. So let's look at it more generally. So let's say I want to graph a function of this form. Where would its asymptotes be? Well, to answer that, we need to look at when things go wrong. What are things in this equation that would cause a problem? So firstly, this m at the front is just timesing by log of something. It's m times a number. Timesing by a number is safe. We don't run into any problems there. Similarly, adding a number at the end is safe. That won't cause us any issues. There's no number you're not allowed to add. This is where the problem will be. The problem will occur if I try to take log base a of something here where this something is equal to 0. Because again, for all of this, we're assuming that a is greater than 0. So if a is a positive number, I can't take log base a of 0 or anything negative. What I'm saying is this part of the equation will cause a problem if x plus b is equal to 0. Then I'd be taking log base a of 0, which I can't do. So if x plus b equals 0, x equals minus b. That is the equation of the asymptote of a graph of this form. So, like over in this example, this will be a vertical line. Log graphs always have one vertical asymptote. So sometimes you'll be asked for domain and range. So we've done this before, but I know it's been a while. So remember, the domain is the set of all values that x can take. So if I'm graphing a function of this form, we always have to have x such that x is greater than minus b. So x has to be greater than minus b so that this thing here is a positive number, because you can only take log of a positive number. So remember, the range is the set of all values that y can take. So what values can y take? Well, this value here can be any number. It can be positive, it can be negative, whatever. If we just looked at, say, log base 2, you can get an answer of -1. For example, log base 2 of a half is equal to -1. Log base 2 of 1 is equal to 0. See, x has to be a positive number. The thing you're taking a log of must be positive, but y can take any value. And we see that in this graph here. There's no value along here that y can't take. This will just keep getting bigger and bigger, albeit slowly. There are certainly values x can't take, but there's never a value that y can't take. Now that makes sense because I told you the asymptote is always a vertical line. So it can't cross this asymptote. There are restrictions on values that x can take, but not that y can take. So this is how you write it. You write y such that y is a real number. This is mathematical shorthand for saying y can take any value. So whenever you're graphing a log function like this, y can take any value, but x has to be greater than the negative of whatever number this is in the brackets, because that will ensure you're taking the log of a positive number. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.